Good evening, friends. Welcome to 360DigiTMG. So today we'll continue our topic, which was our AI-powered image generation tools. Okay. So in the previous lecture, we have understood about various tools, which was Stable Diffusion, Midjourney, Clip, Blip 2, Vision Transformer. And now in the today's lecture, we are going to understand about DAL-E, Imagen, Stable Video Diffusions, and so on and so forth. So let's start our session. So start with our DAL-E. We have understood about the vision transformer, applications of vision transformer, and today we are going to understand about the DAL-E3, okay, which is an image classification tool. Okay, so here we'll use our vision transformer, which will excel at classifying the images into predefined categories like animals, objects, or scenes. It can be useful for object detections. It can identify and localize objects within an image, which will be potentially pinpointing their positions and bounding boxes. It can be used for image segmentations. Vision transformers can be used to segment images which are aligning in the same pixels to a specific categories, which will allow the task like background removal or for object segmentations for self-driving cars. Okay, so these are all the, even we can use it for image retrieval task. Vision transformers' abilities to understand image contents will allow for significant image retrieval systems. It will use for finding the similar images based on the query image or a text description. We can use it for fine tuning for a specific task. Whatever task we want, what is our business problem, according to that, we can use it for fine tuning purpose. Vision transformers can be fine tuned for specific computer vision tasks beyond our general classification, such as medical image analysis, anomaly detections, or visual question answering, and so on and so forth. Okay. So suppose we'll give a text prompt as an armchair in the shape of an avocado. So see here, the AI generated images, we can see it is at the shape of avocado. Okay. So this was a simple prompt and see, these are all the outputs. So how DAL-E3 working and architecture works actually. So it is a model integration. We'll see first DAL-E, a core image generation model which is responsible for translating a textual description into a visual representation. Whatever we will give a prompt in a textual format, it will take it and it will give us a visual representation according to our prompts or according to our requirements. Just as that of ChatGPT. ChatGPT uses a conversational AI model, which will likely used for refining user prompts, providing the feedbacks and suggestions based on the user's descriptions and the generated image. And it can be useful for interactive image creations, which will enable a back and forth conversations where the users can provide further instructions or request modifications to the generated image. Here, apart from model integrations, here there is an architecture called GAN architecture, which is Generative Adversarial Network. It is an initial image generation. What we will do is, based on our textual input, we will do our DAL-E3, will create a starting image using a techniques called transformers and convolution layers. It will use iterative refinements. It will have generator networks. This network will continuously refine the image, which will incorporate the feedback from the discriminator networks. And potentially, it will give us suggestions. It will take a suggestions from ChatGPT itself. Discriminator will do what? Discriminator will evaluate whatever the generated image will be present. It will evaluate whether that image is a real one, real photograph, or it has been taken from somewhere else. Okay. And then there is third is our core image generation process. So here we will use a text processing where we'll have the user textual prompts where we will convert into the prompts into a vector representation using a techniques like transformer. Okay, whatever the inputs or whatever the prompt we will give, it will be converted into the numerical or vector representations using a transformer architecture. Then the image generation will occur. The encoded text descriptions serves as a foundation for the initial image creation process. There will be an iterative refinements. Through multiple iterations, the generator networks will provide the image which will be based on the discriminator's feedback and potentially a ChatGPT suggestions. The discriminator assesses the improvements, aiming to classify the generated image as a realistic or non-realistic or real or fake. Likewise, then the final output will come. The process will continue as a satisfactory image is achieved. As and when the satisfactory image is achieved, we will keep it. We will have a balanced visual quality and alignments with the textual prompts. Then these are all the comparison versions of DAL. DAL-E was released on January 2021. Then DAL-E2 was released on April 2022. And DAL-E3 is not publicly available yet. Okay. So we can see all the features amongst these tools. Then we can understand about the DAL-E3 applications. So it can be useful for the creative industries. We can generate a concepts like art, instructions, and designs, elements based on the descriptions. Whatever the description we will provide or user will provide, it can be aids to like artists, designers, and storytellers. Okay, it can be helpful for all the purposes. Then content creation. We produce a unique and engaging visuals for social media, marketing materials, and blogs posts, which will enhance the audience engagement. It can be useful for educational and communication purpose, which will create our visuals for explainers video, which can be useful for presentations and interactive learning experiences, which will foster our better understandings. Then there are other potential applications related to this. We'll use it and generate the 3D models. We can use it for whether it is a prototype or personalized avatars based on our users' input. Okay. Then it can be useful for exploration and innovation purposes. Then there is Imagine. Imagine is an AI innovation. Imagine is a cutting-edge text-to-image AI model developed by Google. It is a creative visuals. So what are the creative visuals here? It generates photorealistic images from the textual descriptions. Versatility, capable of creating a high-quality images from a wide range of text inputs. Advanced technology, it utilizes the deep learning techniques and diffusion models for image generation. Then there is boundary pushing. It will represent a significant advancement in the field of AI-driven creative content generations. With the given number of prompt or whatever the prompt we are providing, okay, based on that prompt, it will convert the text into the image model. Okay. So likewise, we can see here the prompt is given and it has given the innovative images. Okay. Then there is text encoder, which is T5. Here, what architecture we are following is our encoder architectures. Okay, encoder architecture. which will convert our textual description into the numerical representation. Whatever the text we are providing, users are providing, we are taking it and we are converting into the numerical representation. We are capturing the semantic information. What are the semantic search present inside our data set, our search engine, and within the user inputs? We are finding out the semantic search for guiding the image generation. Then we are having a diffusion models, core generative components that will start from the noise and iteratively refines it into the detailed image, which will be based on the text encoding. Then there is caption conditioning. It will integrate the textual information with the generative process, which will ensure the output image will be aligned to the description, input description. Whatever the input description we are providing, it should be according to that only, whatever the output or images are generating. Then super resolution model. It is having a super resolution model, which will upscales our initial low resolution images from the diffusion model to a high resolution outputs, which will what? Which will enhance the images quality. Then we'll have a classifier free guidance. It is a technique to fine tune the balance between the image finality and diversity, improving the alignment with the text description. Okay. Then how it works, how Imagine this work. So Imagine will work on the input processing. Okay, so it works from the process will begin from the textual description, means our input, such as a sunny day in San Francisco with a Golden Gate Bridge in the background. See, this is our input. Okay, now what it will happen? It will take our text input and it will convert into the encoder activation. This input is fed into the T5 text encoder, which is a foundation model. Okay, then it will translate the text into the high dimensional numerical representation that will capture the semantic search, semantic essence of the description. What is the actual semantic description of this thing? And then it will generate some images with respect to that. Then there is initial image generation. By using a diffusion models, images will start a pattern of noise and iteratively it will refines this into the initial low resolution image that will correspond to the textual descriptions. Okay. Textual descriptions, semantic content, whatever the textual description and the semantic content, whatever is present. For example, starting from the noise, the model might first outline the basic shapes of the landscape, gradually refining these into the recognizable elements like water, sky, and the Golden Gate Bridge as described, whatever will be described. So it will first consider what the basic shapes of the landscape. Okay, it will first carry out the high level features, then mid level features, and then low level features. Okay. Then it will have a caption conditioning. Throughout this process, the diffusion model is conditioned on the text encoding. It will ensure that each step of the refinement is guided by the textual descriptions. This means elements specific to a sunny day in San Francisco and the Golden Gate Bridge are progressively made more prominent and accurate. So we will take it and first we will take the encoder, we will use it. What we are going to do, this is our image. Okay, so whatever the text we are giving, it will be converted into the text encoder format. It will take some time, and then whatever the output will be generated, it will be in the form of conditional output. Means it will take some time and it will find out, it will have some pooling layer extracting the most important features from the text, and then it will convert that into the conditioned image format. Okay, then there is working. As we have seen, the super resolution enhancement. it will have a super resolution enhancement in the images. The initial low resolution images will be there. So then it undergoes a series of super resolution steps where it is upscaled to the high resolutions. Like each step not only increases the image size, but also it will enhance the details present, which will be undergoing to the textual description, which will be aligned to the textual descriptions. Okay, so first the output was like this. Okay, while giving some importance, while having some detail according to our textual description, it will then align and give the images like this, high resolution images. The first super resolution model might take the image from 64 by 64 pixels to 256 by 256, which will adding the finer details like textures of the water and bridges, cable, so on and so forth. The second super resolution steps will increase the resolutions from 256 by 256 to 124 by 124 pixels, which will then introduce minute details such as play of the sunlight on the bridge and the ripples in the water, fulfilling and realizing the sunny day aspects. Okay, so this is how the minute details will be there. Firstly, the output will be like this, and then the super resolution enhancement. After having super resolution enhancement, the images will be like this. Then there is classifier free guidance to improve the fidelity of the generated image to the input text. Classifier free guidance is employed, which will be adjusting with the model's parameter to emphasize certain aspects of the descriptions. Okay, then it will have a final image output. The final image output will be a high resolution photorealistic image, which will be visually represents the original text description. For our example, the final output will be a detailed and vivid images of sunny day in San Francisco with a clear, well-defined Golden Gate Bridge in a background, effectively capturing the intended scene. Okay, so this is how we can improve our image outputs by using an Imagen tool. So this is an output when we are using Imagen and when we are using the DAL-E. Okay, so these are all the whatever the focus they are doing. Okay, whatever the technology they are using, large transformer they are using a GAN architecture, which is a transformer only. Okay, and user interaction is limited here, but here the user interaction will be interactive as that of chatbot. Okay, then strength will be a high photorealistic images will be formed. Here the creative and imaginative visuals will be formed. Okay, so these are all the working, or what we can say, the advantages of using these things and features which are more likely to be in Imagen and DALL-E. Then there is a stable video diffusion. Stable video diffusion, SVD, is a type of deep learning model which is designed to generate short videos from a still images. Okay, from a still images, we are making what? We are generating a short videos by using a stable video diffusions. It will take a single image like conditioning frame as an input. It will then analyze the image content and understand its visual elements. And then it will generate a frames that progressively evolves and creating a short video clips. It will have a diffusion models. Okay, so these models will start with a random noise and gradually it will refine it, incorporating the information from the conditioning image to a coherent video. Then it will generate a realistic and visually consistent short videos. Typically, it will be now 25 to 50 frames, which will be aligned with the content of conditioning image. It will allow for some level of controls over the video content through a text prompts or additional image inputs. Okay. So this is how we are going to generate our short video with respect to a single image input first. And by using a model called diffusion models. Here we are generating a short video. Suppose we are using 25 to 50 frames from a single image. What is the working of it? So working is, first we are taking a conditioning image. We are analyzing the visual elements of this image, and we are creating a sequence of frames progressively evolved based on the conditioning image. Based on our original image, we are progressively evolving our image and generating a video. So what type of architecture we are using here is a diffusion model core. So it will start with a random noise and it will refine step by step. Okay, it will refine step by step, which will incorporating the information from the conditioning image. Okay, so it will have a potential support. Suppose, for example, we are using a CNN, that is convolution neural network, which might be used for feature extraction from the conditioning image and aiding to the diffusion process. Okay, so here what we are using, here we are using a cross attention. Okay, we are taking our image and we are making into the short video or conditioning formats of the videos. Okay, for that we are purposefully adding a diffusion model here. Okay, frame by frame we are adding it and we are supposing to concatenate that, and then we are generating our output with respect to our given search. Okay. Then there is a creative tools which offers a novel approach to video creation, which will enable the user to generate short video snippets from the static images. Okay, from a static images, we can generate a small videos with respect to our given, enabling the user whatever the user wants according to that. Then these are all the applications and benefits with respect to our stable video diffusion model. Okay, here it is having an efficiency which saves and which will save resources which compared to that of the traditional animations or video editing processes for the specific task. Then we'll have the accessibility also. It lowers the barrier to enter for the video creation, which will allow the users without extensive video editing experience to explore basic video generation, how we can generate a basic video from that. Here we can use it for animation and storytelling purpose. We can use it for video editing purposes. Likewise, we can use it for visual effects like reducing or the effects of the special effects like fire, smokes, or water simulations. And we can create it for surreal video sequences for innovative visual storytellings. Then the challenges and limitations with respect to stable video diffusions. So it has a limited video length. Since we have already said that it will be a short video, which will be having only 25 to 50 frames. So it will not take a longer video content. So this is one of the drawback. Controls and details. Offers limited control or specific condition, actions or details present. Because as in how the data, or what we can say, the frames are lesser, so we'll have lesser numbers of detail. Then the video quality might not always perfectly match with the conditioning image. Then ethical concerns, potential for misuse in creating of deep fakes or manipulating the video contents. This is actually very this thing. Then concern thing. Then there is rapidly evolving fields. As we have seen, stable video diffusions is under development, so its capabilities and limitations might change as research and technology progresses. Then there is EMU videos and EMU editor. So it is introduced by Meta, Facebook. EMU videos, this model focuses on creating short videos based on user provided text prompts. Okay, it will create a short video based on text prompts. Okay, earlier what we have seen, it was taking one image, and then from the one image it is considering and making 25 to 50 frames and generating a video. Here in EMU, it is generating, user will provide a text prompt, and according to that text prompt, the videos or short videos will be generated. Then we'll have a text-based prompts, as we have seen. Then the potential architecture with respect to this is GAN architecture. We are using a generative adversarial networks for doing so. Then there will be having a interactive editing. EMU video might integrate with Meta's conversational AI. It will, or chat GPT, which will allow to provide real-time feedbacks and refine the generated video based on the preferences. Then there will be what is the working of EMU, how it works. So it works on the, first we'll see the factorized generation process, how we are going to generate it. So we are making the EMU video, which will be decomposing of text to video generation into the two discrete steps. First will be our image generation. First, it generates an image based on the input text. Whatever the input text we are providing, it will generate a text or generate an image. After that, after generating an image, it will generate a video. Subsequently, it creates a video conditioning both the text also and previously generated image also. This second step will progress into the diffusion models, which will allow for more accurate and higher quality video outputs, which will leverage the strong conditioning provided by the initial image. Then there will be having a design decisions, which will utilize our adjusted noise schedules for diffusions, which will maintain a high quality and resolutions without needing a deep cascades of models. Okay, then there will be human evaluations. It will demonstrate superior performance in human evaluations, surpassing the other models and commercial solutions in quality and text faithfulness. Okay, here there will be a human evaluation as well. So it will make a, since human involvement is also there, it can make the model more commercials, and it can make a more quality and text will be more faithful as compared to the other. Then here we are using the architecture we are using is, what architecture we are using? We are using a pre-trained text to image model. They are not displaying what model they are using. They are saying just we are using a pre-trained text to image model, which is kept mostly unchanged to leverage its image generation capabilities. It will have a temporal parameter additions. It will introduce our learnable temporal parameters like 1D temporal convolutions and attention. And it will take our model to handle video frame generations. Then we'll have a training approach. It will start with easier task first. It will have a easier task first. It will generate lower resolution videos first before progressing to a higher resolutions and longer duration videos. Okay, it will optimize the model's performance. Then it is having a image conditioning. Since we are taking our image by zero padding it temporarily and using a binary mask to integrate or to indicate the positioning of the initial frame within the zero sequence. We are using a noise schedule optimization, which will adjust our diffusion noise schedule to address our discrepancies between the training and interference, which will ensure a consistent video quality should be there at high resolutions. Then these are all the examples which are related to, like first we are going to, the step 1 will be image generation, the step 2 will be the video generations. Okay, firstly there is one prompt, text prompt is there. From this text prompt, it will first generate some image. After that, from this given image, we will generate our video. So this is our output. This is our output. So here we can see the key features demonstrated is quality and resolutions. The generated quality is of high quality and resolutions. Temporal consistency, the movements of the fox and the surrounding environments are temporally consistent. Then faithfulness to text. The video accurately reflects the content of text prompt that will demonstrate the model's ability to understand and visualize the complex scenes as well. Okay, so this is our EMU model. Then there is a SDXL turbo model. We'll understand this model on the next Saturday, on the next lecture. So till then, goodbye. Thank you for joining. Goodbye. Thank you.